Hi, everyone. My name is Jim Siegel. I'm at the National Conservation Training Center in Shepherdstown, West Virginia. And thank you for joining the Climate Adaptation for Forest-Dependent Wildlife webinar series. This is the third part of our series, and we're going to be hearing a talk about forest carbon cycle by Dr. Todd Ontl of the National Institute of Applied Climate Science. But before we get started, I'd like to just give you some background on our setup, and so that you can watch and participate in the webinar accordingly. To connect your audio, please select the audio settings at the bottom of your screen. You should be able to switch some audio and change your audio settings. Next slide, please. The Climate Adaptation for Forest-Dependent Wildlife webinar series is a project of the U.S. Fish and Wildlife Service Forest Ecology Working Group, our Science Applications and Migratory Bird Programs, and the National Conservation Training Center. And we are joined in this project by the USDA Forest Service and the Northern Institute of Applied Climate Science, NIACS. The Forest Ecology Working Group contact is Jeff Horan. You can see his email address there. If you have any registration or technical difficulties, please contact me at jim_siegel@fws.gov. And if you are interested in continuing education credits, either available through the Society of American Foresters or the Wildlife Society, please contact me after the talk and I will give you the ways of doing that. SAF requires me to put in some paperwork. TWS is entirely self-reported. Next slide, please. This talk is for educational purposes only. The views, opinions, or positions expressed in the series are those of the guest speakers and do not necessarily reflect the views, opinions, or positions of the U.S. Fish and Wildlife Service or the Department of Interior. Some of the materials and images may be protected by copyright or may have been licensed to us by a third party and are restricted in their use. Mention of any product names, companies, web links, textbooks, or other references does not imply federal endorsement. This webinar is being recorded live, and you will be using the chat function to ask questions as they arise. The webinar recording will be available through the NIACS website, which we will post so that you know where to contact that. The chat function is, you can see there below. You can type in your question, select everyone in the drop-down menu, and just press enter to submit the question. We are going to be answering questions kind of midway in the talk and at the end of the talk. And then any questions that are not answered during our webinar, we are going to save those, and Todd will try to answer them offline, and I'll make those answers available to you after the webinar is over. This 12-part series tells a story about climate change and its impacts on forest ecosystems and forest-dependent wildlife. We'll examine forest ecosystems and their composition and structure under a changing climate and the influence on wildlife populations and on carbon dynamics. We will also share the tools and management approaches to help facilitate forest and wildlife climate adaptation at both landscape and stand scales. Go ahead, Maria.
Great, thanks. Thanks so much, Jim, for kicking us off. Welcome, everyone. I'm really glad that you were able to join us today on behalf of the team of folks who have developed this particular webinar series. We're really glad to have you here for the Climate Adaptation for Forest-Dependent Wildlife webinar series. I did drop the link into the chat for people who want to be able to watch the recorded presentations as they're available if you miss any. I think Jim gave us a nice overview in terms of our efforts to think about how climate change is affecting forests and how that affects wildlife. And today we'll be taking a deeper dive with Todd Ontl, who will talk about the forest carbon cycle and how carbon dynamics, forest carbon dynamics intersect with climate change impacts, adaptation, and wildlife. And this was also noted in the chat too, for those of you who saw it. We ended up rescheduling Olivia Ledie's presentation. Olivia Ledie is with the US Geological Survey and the Midwest Climate Adaptation Science Center. She is going to be giving a presentation for this series on climate change impacts on wildlife. And that was rescheduled from May to next Tuesday, June 28th at 1 o'clock Eastern time. So we hope that you'll be able to join us again next week. All right, so in terms of Todd's presentation, I'm going to introduce Todd, who's my colleague at the Northern Institute of Applied Climate Science. Todd is a climate adaptation specialist with the Northern Institute of Applied Climate Science, NIACS, and Michigan Technological University. His work really focuses on assisting natural resource managers in integrating climate change adaptation in land management. And Todd has really unique interests and experience in adapting decision-making and synergies and adaptation to really focus on carbon and greenhouse gas mitigation in in forest and land management. So Todd has a really great background related to carbon. It includes a Master of Science in Plant Community Restoration, a PhD in Plant Soil Interactions and Soil Carbon Dynamics, and postdoctoral research in climate change impacts on peatland ecosystems. And so I really appreciate Todd's ability to blend ideas related to climate adaptation and responses to changing conditions with increased interest in also addressing carbon mitigation. So I'm going to turn it over to Todd. Please submit your questions via the chat and we will try to answer those midway through and at the end of the presentation.
Thank you, Maria. Thanks for that introduction. And thanks to all of you for choosing to spend part of your morning or afternoon, depending upon where you are, hearing a little bit more about as Maria said, blending these ideas of climate change, climate impacts, and adaptation and carbon. Let me get my slides up here. Okay. Yeah, so I'm going to discuss some of these ideas on the forest carbon cycle and how we can harness actions that we can take for climate adaptation to enhance our carbon or our carbon mitigation goals, and what do those mean for how we manage forest ecosystems for wildlife, for forest-dependent wildlife. Just really quickly, you've heard already from Maria about and Jim about the Northern Institute of Applied Climate Science. I just wanted to give a real brief introduction to our organization. We're a multi-institutional collaborative. We're chartered by the USDA Forest Service, as well as various universities, nonprofit, tribal conservation organizations, and an industry organization. And our work really focuses on developing science synthesis products, fostering communication, and providing technical assistance in climate change adaptation and in carbon management. So that's who we are. As you all know, there's been a lot of discussion and interest in forests for their ability to offset and store carbon. It's one of the terms of natural climate solutions. And this interest really stems from the recognition that forests in the US are able to offset somewhere between 11 to 15% of our total carbon dioxide emissions that come from fossil fuel burning. And forests contain 2/3 of our terrestrial forest carbon stocks. So contain the majority of carbon that's in our land-based ecosystems, and are a very impressive 90% of our land sector's capacity to sequester carbon. And you can see that represented here in the map from the 4th National Climate Assessment, just kind of showing where in the US, there are these hot spots shown in the greens, blues, and purple colors where forest production. And so this is really representing that ability of forests to sequester carbon. Really shows up in the Pacific Northwest, in the Gulf Coast, all really up into the eastern and northeastern US, as well as in the northern and south central portion of the US. So forests really have an amazing capacity to sequester carbon. Right, so we're interested in carbon. We're interested in forests for this climate mitigation, this carbon sequestration and storage capacity. But we also have to recognize that that the climate change that we're trying to mitigate through forest management, that those changes to our climate system are also impacting forests. And so this really is a cycle between forests and the climate. And so, while we recognize the importance of forests for climate mitigation, we also have to recognize of equal importance is those changing climate conditions put the forests and the carbon that they sequester and store at risk, which really gets to the importance of thinking about adaptation and integrating adaptation into planning for effective carbon management in our forest systems. But before I get into some of that, what that looks like, I want to start out by just making sure that we're all on sort of the same page and understanding some of the concepts for carbon management that are important for planning for effective mitigation. Throughout this presentation, I may kind of default to talking about carbon benefits. What do I mean by carbon benefits? Well, it really is a broad term to describe both carbon storage and carbon sequestration. These terms are used frequently. Sometimes they're used in ways that are kind of interchangeable. Sometimes people talk about carbon being sequestered in the environment when they actually might really be describing carbon storage. And so it's important, I think, to just make sure that we are understanding the definitions, because they're very important for thinking about how we can manage carbon. So storage really relates to the amount of carbon that's retained in what we call a carbon pool in the forest. Pools are things like soils, live trees, those sorts of things. And carbon storage is described as sort of a carbon density unit. So the metric tons of carbon per acre or tons of carbon per hectare, that's a carbon density that really is describing that storage. Now, on the opposite side of the coin, kind of the flip side there, is sequestration. And this is really the term that I think gets used in a lot more various ways. But sequestration, from an ecological standpoint, is really referring to a flux, a carbon flux, and that flux is being driven, or the process is being driven by plant photosynthesis. So it's plants that are removing carbon dioxide from the atmosphere and turning it into biomass or using it for the maintenance of their metabolism. Oops. Carbon benefits are also provided by a lot of different forest stand conditions. Now, I sometimes get asked by people, how should I manage or how should I be managing for carbon in my forest? Should I be managing for sequestration or for storage? Should I be managing for older forest stands or should I be managing for younger forest stands? The answer that I like to give is yes. And that's really the recognition that these two ideas of carbon storage and carbon sequestration are represented in both a lot of different stand conditions. And you can kind of see here in this figure that, it's just the balance of the two kind of depends upon the type of condition. So in a mature forest, we have abundant tree biomass in these large diameter trees. That's storing a lot of carbon. But mature forests have relatively lower carbon sequestration rates on a per acre basis relative to younger forests, which have less carbon stored because the trees are smaller, the trunks are smaller, but those trees are growing very quickly. And so there's very high carbon sequestration rates in these young forests. So really the type of carbon benefit you get is sort of dependent upon the stand characteristics, but you're typically getting both from a healthy forest stand. Now this figure just kind of is another way of looking at that carbon storage between young and old forests. This is looking at carbon storage dynamics across forest stand ages. And you can see here, we've got multiple carbon pools indicated here. The total amount of carbon in a forest ecosystem shown in that dashed line on the top. And you can see that at young forest stand age, say between 0 and 25 years, that most of the carbon is in the soil, but that over time, carbon in those live trees grows very quickly. And really the change in total carbon kind of tracks the change in the live trees. So trees are really, tree growth is really driving that change. And this inset here is some data from Bill Keaton at University of Vermont, just showing kind of what that looks like beyond this 125-year time period into kind of these old growth stages of forests, and just showing that indeed carbon still continues to accumulate even at very old ages. And I want to give credit here to my colleague Ali Kusiba at the Vermont Department of Forest Parks and Recreation, who created this figure as part of their Securing Northeast Forest Carbon program. And just to also, so Ali used data from a maple beech birch forest in the Northeast. So this would look different depending upon what region of the country you're in and what forest type you're interested in looking at. Now, Ali also kind of graphed out what the carbon flux or the sequestration looks like over time as well. And I think this is a really interesting and really shows that that young forest stands sequester carbon very quickly. Here you can see, and I should mention here now, negative numbers indicate movement or flux into the ecosystem. So that's sequestration. Anything that's positive is an emission back to the atmosphere. And you can see here, again, live trees, it's shown in green. That sequestration rate is really highest kind of in those young stand conditions below 50 years of age. But it's not all driven by live trees. We also have some of these other carbon pools that are contributing, particularly at those young age classes. And this inset, again, showing what happens beyond into those old growth stages. And what we can see here is that, as forests age and get over, 200-300 years old, that carbon flux really slows down. It never here it isn't showing that it's getting to be zero, but it's getting very close, and it's really emphasizing that those old forest conditions are really contributing less and less carbon annually to the carbon stored in the forests. So when we think about management actions, things that we can do to enhance carbon, I'd like to equate this to kind of thinking about, well, how do you grow your bank account? It's really about the balance between the inputs and the losses to your account. So you can think about ways that you can increase the amount of money flowing into your account, or the amount of carbon flowing into your system. You could also think about the losses, the amount of money flowing out of your account. So you can change either one of these or both in order to have a positive effect on the balance. What matters over time is really that we see a net gain over time. And it's important to note that carbon dynamics and carbon fluxes oftentimes occur at slow rates. So the time scale that we're talking about these changes are often decades to centuries, but not always, as we'll see here in some of the slides coming up here. But some of the things that we can do to increase the inputs, we can think about enhancing productivity of trees, which, enhancing that sequestration rate, as well as, are there opportunities to transfer carbon from that live tree pool into some of those other carbon pools? As long as we're maintaining those productivity rates, that's an input to the system that is a net gain. We also can think about reducing unplanned or unintended carbon losses. And these are some of the things, that we are oftentimes thinking about very strategically when we think about forests and forest management. How do we reduce the risk of catastrophic wildfire? How do we reduce risks for tree mortality, whether it's from drought, pests, or diseases? All of these represent forest carbon losses, some of which can occur very quickly and some of which may take many years or decades to play out. So just to dig in a little bit more on these management options for increasing carbon inputs to the system, we can think about how can we enhance the growth of our existing mature trees. Some of those actions might look like doing thinning around our our healthiest mature trees to give them more room to grow, less competition for water and nutrients. Improving forest health, so that, again, that those trees can maintain high growth rates and aren't impacted by some of the stressors that are always at play in our forest ecosystems. Of course, we always need to be thinking about regeneration at the next generation of trees within our forests, and making sure that we're maintaining regeneration opportunities, because that's the future productivity of our forest. And all of these things really add up to, over time, increasing stocking levels. Now, it's not just about productivity and regeneration. Of course, I mentioned existing carbon pools, things like soil, litter, of course, woody debris, understory vegetation. These are all minor components of the total ecosystem carbon, but they are important, and there are a lot of opportunities that we can look towards for enhancing carbon in these pools as well. And that's particularly true in forest systems where some of these other carbon pools might have been depleted from past management or from disturbance. And so we not only want to focus on this CO2 flowing into the live tree, but recognizing that carbon flows through ecosystems, and so that carbon eventually ends up in these pools as well. And where appropriate, we can be enhancing carbon in these pools. And I say where appropriate because there are some places where this dead wood represents a risk for wildfire. And that's, again, one of the things we'll talk a little bit more about, but that represents a risk for a carbon loss. So in some of those systems, it may not be appropriate to focus on that dead wood carbon. But by doing this, we are enhancing the complexity of our forest ecosystems. We're enhancing the habitat value. And so this is a really good win-win, I think, from a carbon perspective and from a wildlife habitat perspective, that where it's appropriate, management to enhance these carbon pools can help us meet multiple goals related to both carbon and wildlife. Now, I mentioned also that the other side of this equation is managing to avoid forest carbon losses. And this is important to really think about how do we assess risk in our systems, both sort of in the short term, but not, it's also important to be thinking long-term, to be thinking, many decades out into the future, and what kind of risk does climate change and other stressors, other disturbance factors represent for carbon loss. And so here I'm showing just some modeled results for 2 different regions in the US, showing habitat suitability projections for 2 different tree species. On the left, we're looking at Douglas fir in the western US, and the green showing kind of current modeled habitat for this species, and the 2 panels to the right just showing over time that Douglas fir is expected to or predicted to lose habitat. That habitat is expected to shrink especially in some of the southern portions of its range, and maybe gain a little additional habitat in the northern portion of its range. And then similarly, we're looking at projections for Douglas fir in the northern tier of the eastern US for balsam fir. This is from the Climate Change Tree Atlas, just showing essentially the same thing, kind of a retraction in habitat suitability for this species, moving further north as the climate changes. And that's being shown in the reduction of those darker blues and green colors, which indicates the importance of that species to the forest in that region. Another really important consideration for management to avoid forest carbon losses is thinking about large scale or intense disturbances. And this really is very dependent upon where you are in the world and what are the climate change impacts, and what are the what are those really important disturbances that might impact your region. And so we're looking at several representations of these ideas here. On the left, widespread tree mortality in Rhode Island from spongy moth, which is an economically important forest pest. In the middle here, catastrophic carbon loss from a crown fire that occurred in Yellowstone National Park back in 2013. And then along the Gulf Coast, tree loss that happened as a result of Hurricane Laura in 2020. These are all events that resulted in widespread tree mortality that increases emissions from carbon in these ecosystems. Now, we might think, well, these are, what are the chances that this is going to happen to my forest? These are rare events. They don't occur. They may not be very widespread. It's important to recognize that, the carbon benefits that we get from avoiding these losses really relate to, it's important to think about, what's the risk of that disturbance happening, but also what's the severity if it does happen? How important of an impact is that event going to have on carbon for that ecosystem? And as I said, the risk may be low in any given year, but it's important to recognize that over the course of years and decades, especially as climate change intensifies, the risk of something eventually happening gets greater and greater. And that's kind of shown here in this map of all the wildfire and insect and disease disturbances that have happened over decades in the Northwest. And you can see that's a significant proportion of the land there that's impacted by one or more of those. So now I'm gonna talk briefly just about how can we kind of put these ideas of climate vulnerability and carbon management together to understand what are maybe some of the things that we can do as managers for forest systems. Well, I think the easiest place to start is to think about, well, if there are systems with low vulnerability to those climate change impacts, there's low risk of disturbance, low risk of tree mortality or tree productivity declines. There are ways that we can look to increase stocking rates, and by increasing stocking rates, we're getting greater carbon benefits. One of the ways to reduce carbon losses is to reduce harvest removals. And this is something that's gained a lot of traction. People have really discussed a lot of these approaches, such as extending rotations or delaying harvest entry, land protection, enhancing reserves where no harvesting is allowed, such as around riparian areas or other sensitive sites. And you can see that here in this just sort of cartoon generalized depiction that under a low vulnerability scenario, that this passive management can result in, essentially the forest aging, gaining more carbon, gaining a little bit more in terms of its complexity, which provides, habitat, wildlife habitat benefits. But integrating that idea of vulnerability and disturbance risk here, now the more carbon we gain in the system, if a disturbance were to occur, such as a wildfire, which I'm showing here with this red line, kind of an immediate loss of carbon through combustion, or productivity declines, which I'm showing in the blue line here, that compared to no climate change occurring, that's a loss to the system, and that the more carbon we have, the greater the loss is. And that's kind of being shown here in this cartoon depiction, that we do nothing, passive management under a high vulnerability, we can end up with much less carbon in our system as tree mortality increases and those events occur. Well, so let's take this to the next step then. Well, when we have systems with high vulnerability, that's where we start thinking about things like climate change adaptation. And so climate adaptation management is shown here in the green. And so relative to those disturbance scenarios, we might think about some action that has an immediate loss in carbon because we've created an opportunity, say, for regeneration of future adapted species. We have maybe an immediate reduction in carbon in the system, but over time, that carbon rebounds as trees regenerate. And relative to what would have happened had we done nothing, we can see that there are carbon benefits that stem from that climate adaptation. And I'm showing that here with a depiction of what the creation of a gap might look like in a forest, where we remove some vulnerable species to create an opening in the canopy, and then that allows for regeneration. And we would be doing this to encourage regeneration of a more future adapted or better adapted species, such as maybe a shade intolerant tree species that's adapted to warmer and drier conditions. And so as those trees begin to grow, you get carbon accruing, and relative to the no management scenario under high vulnerability, you have more carbon in the system. And then finally, let's go back to that low climate vulnerability scenario. We can think about ways that we might be able to institute or implement active management that's really geared towards enhancing sequestration. There are forest management options. Some are known as things like structural complexity enhancement, single tree selection, a whole host of different actions which minimize that short-term loss and really bump up the sequestration and also enhance forest stand complexity, and which I'm showing here. And so you're getting a lot more vertical complexity, more diversity in your forests, your development of some of those features like snags and logs, which represent some amount of carbon being stored, but they can be really beneficial for wildlife as well. And so this is sort of that best case scenario from a carbon standpoint where we've kind of enhanced the sequestration, but we've also retained a lot of kind of what was already there. And so really to drive this point home, this idea of integrating adaptation and mitigation together, really the goal is twofold. It's enhancing sequestration, but making sure that sequestration is resilient. And so if the system does suffer disturbance or an impact, those sequestration rates are able to bounce back. And enhance the residence time of carbon in the ecosystem as well. So we may take a little bit of a hit, we may lose some carbon in the system, but the carbon that remains and the carbon that we regain over time is more, has longer residence time. It's more, it's going to be less impacted, I should say, by future disturbances. So I think we're going to take a pause here.
Yeah, great. I'll let you get a half a breath, Todd. But I've been monitoring the questions. Keep them coming in. We'll have more after the presentation is over, and we can even stay on a little bit after the hour if there are questions. It's been really great. I am going to give you 2 rapid fire questions, Todd, and then one that's going to be a little more nuanced, just so we can keep things moving. But there was a quick question about, the map you showed early on of, I believe it was carbon stocks, did not have Alaska. It had the coterminous US because of the FIA data. Do you just want to comment really briefly on sort of where Alaska and other parts outside of the lower 48 fit?
Yeah, good point. And I recognize that sometimes Alaska gets short shrift on some of these mapping products. So there are obviously forest growth, and that map actually was showing sequestration rates of forests and showing where the forests are growing most rapidly. And so, some of the Hawaii and Puerto Rico, those places, they're in the tropics, warm, wet environments, trees grow very rapidly. And similarly, in some of the temperate rainforest regions of Southeast Alaska, similar, there can be very rapid tree growth. And as you get further north and you get much colder and the growing season is much shorter, that sequestration drops off quite significantly. And so, the value in carbon in some of those more boreal ecosystems that we might find in sort of the northern portion of Alaska before the tree cover turns to herbaceous ecosystems, is really more about the soil, because of the cold temperatures are storing more carbon because of the lack of decomposition. But sequestration rates can really drop off when you get into those cold ecosystems.
Thanks, Todd. And that also kind of addressed one of the people asking by you clarifying, and I missed it, it was sequestration, was that it shows why it's so high in the Southeast is just related to growing season and growing conditions.
Correct.
There was great. And there was one other quick question was related to soil carbon sequestration. And I think if you just want to clarify kind of role of soil carbon and how much, kind of how that relates to your presentation that I think is mostly focused on above ground, but if you want to just provide a little more clarity on that.
Yeah. And yeah, I appreciate the question, because yes, as Maria mentioned, we are kind of focusing a lot more on the above ground portion, but I briefly mentioned that in that one figure that showed kind of at young forest ages that soil carbon represented most of the carbon in the ecosystem until the trees kind of gained in their carbon stocks. But that's really dependent upon where you are. And soil carbon can be half or more than half of total ecosystem carbon, even in a mature forest. And there are other ecosystems such as forested peatlands where the below ground carbon component is immense, and far many times higher than what carbon stocks are in above ground. So it's really dependent upon the forest type and the ecosystem just in general, your climate. But below ground carbon is very important, and in particular, it's very important because of here we're looking at this slide saying residence time of ecosystem carbon, and that's really where soil carbon shines, is that it has a very long residence time. It changes very slowly, so it's hard to gain it. As long as we don't beat up our soils, it's also not something that we lose very readily. And but recognizing that we can lose it quickly if things kind of go sideways on us when we're doing management. For example, through erosion or compaction. But soils are they're a very stable carbon stock, and from that, and they're also a very significant carbon stock. So for both of those aspects, soils should not be ignored. But we do have sort of fewer levers that we can manipulate in terms of the gains to soil carbon, because it does accrue so slowly in our ecosystems.
Thanks, Todd. I'm looking at the time, and I want to sneak one more in if it works for your presentation. I think this is fine, because then we can so there's one that's coming in about deer herbivory, so you might tackle that as we're kind of going through. There's the moose one. We'll tackle those at the end. We'll get a COSIBA 2022 reference at the end. I think the other piece that was coming up, and I think you hit on this in a number of ways, but I think also just because it is a topic, is let's see here. I think it's the idea of young forests sequestering fast versus old forests storing a lot. And I think there were some comments, and we can dig into these a little bit more deeply at the end, but about, that being a helpful construction, but also sort of an oversimplification sometimes, and certainly something that people are thinking about in terms of, later successional forests, more mature forests, old growth forests. And so I'm trying to see if it's hard to pick out a single question, but I wondered if you wanted to just, you deal with this, if you wanted to kind of comment a little bit more on sort of maybe a little bit on how much we know on the ecology versus how much we're still learning, I think is sort of where the questions were.
Yeah. Huge topic, and a very important one, and certainly capturing a lot of the conversation around natural climate solutions in forests right now. So it is an oversimplification there, and there's a lot of buts we could say about any of these things, right? So we're kind of scratching the surface. I just lost my train of thought on what what I wanted to say on that. But shoot. Yes, I will say that, from the perspective of, thinking about forest protection, how we want to kind of balance these things. Oh, I know what I was going to say. Maria, you mentioned sort of what we know and what we're learning, and that is important. And I think we are learning a lot about sort of the value of old forests in terms of their ability to sequester additional carbon. That has been something that has come up in the literature. I think some fairly important papers that have really kind of shifted our paradigm on how we understand that. And one thing to mention is that, kind of moderate or small scale disturbances that kind of create these small openings in the canopy, those are opportunities for regeneration, an opportunity for a suppressed tree to make a sprint to the canopy and grow very quickly. Those occurrences have been shown to really maintain that sequestration in the face of sort of things slowing down in general. And the other thing to say is also that, we talk about mature forests growing or sequestering carbon slowly. That's on a per acre basis. That's because much of an acre might be occupied by just a few large diameter trees. And so those individual large trees may be, even though they may be very old, they may be sequestering carbon at a fairly rapid rate still, but much of what is, suppressed underneath the canopy is not sequestering very much carbon at all. And so that's why we think about it on a per acre basis. And so that sometimes elicits some of that, yeah, but, and we just need to make sure that we're kind of talking the same language and comparing apples to apples. But we are gaining a lot of understanding about the value of large diameter trees for what they contribute to both carbon storage and carbon sequestration. And so, that is, I think, a rapidly evolving body of, of our understanding of the science of carbon dynamics in forests.
Thanks, Todd. Yeah, I think you captured a lot of what people were looking for. If there are follow-ups, put those in the chat. And so, yeah, let's finish out your talk, and then we'll hit a few more of these questions at the end.
Okay, great. Well, I do want to make sure that we really tie this to wildlife habitat, and as well as also just kind of, recognizing that there are trade-offs. There are always trade-offs in how we manage our ecosystems. You can't kind of have everything all at the same time. And so, sometimes people come to the topic of managing forests for carbon from a perspective of, well, we must be considering how can we be maximizing our carbon benefits on our forest lands. And it's really, I think for many, kind of a baseline of thinking about, we want to get the most carbon mitigation value from these forests because of their importance as a natural climate solution. And when I hear this question, I really try to kind of redirect and say, there's a lot of values that we have to be thinking about when we're managing our forests, particularly on our public lands. Carbon is not the only thing. And so from that carbon perspective, I think a more relevant question to ask is, are there carbon practices that we can implement that can help us achieve our mitigation and our other desired goals? So, looking for those win-wins. Can we be, enhancing carbon stocks while also enhancing ecosystem health? Or are there trade-offs? Can we be enhancing carbon stocks and enhancing water quality protection or water quantity? Can we be enhancing carbon while we're still generating wood products, which is We haven't talked about wood products yet because we're really focused on forested ecosystems, but carbon is stored in harvested wood products, kind of depending upon the lifetime of those products. So I think the place to start is to really kind of look for where are those win-win situations where we can be working towards multiple goals. But we can't always do that. There are many instances where the trade-offs exist, and it's important to recognize them. Just looking at the left-hand panel of this slide, this is from some work that we did at NIAX a few years back, where we were just trying to understand, what were managers thinking about when thinking about adaptation. And an interesting result that we saw, and this was really kind of regionally dependent. This was some results from some of the adaptation projects we developed in the Central Hardwoods region, kind of in like Southern Missouri, Southern Illinois, Southern Indiana, was that managers were really thinking a lot about transitioning their systems through restoring forest conditions. So in the past, they had, a certain structure and a certain species composition, but over time, through the lack of fire, through the lack of active management, shade-tolerant species kind of filled in those systems, and we had a very different structure, closed canopy conditions, and a different composition where we had a lot more of that shade-tolerant species. And so managers through their adaptation, they were really thinking about transitioning the systems back to something that looked more like what was in the past by opening up the canopies and restoring more open woodland conditions and kind of shifting back to maybe some more of those pine species or oak and hickory species, for example, for that region. And so, this is a trade-off. By doing that, they're removing carbon from the system. That ecosystem is going to carry fewer or lower carbon stocks. But the idea here is that those systems will be more resilient. They'll be more adapted to the future conditions. And so going back again to that point that I was making a few slides back, that, the carbon that is remaining there in those systems, which is significant, will have a longer lifetime. It'll have longer residence time on the landscape because it's more adapted to those conditions. And some of these ideas have been described really well in this paper that came out last year by our colleagues Caitlin Littlefield and Tony D'Amato in their Conservation Science and Practice paper, where they were exploring this idea of carbon trade-offs for wildlife habitat. And they took a look at 4 different habitat types: really successional northern hardwoods, tallgrass aspen parklands, oak savannas, and pitch pine scrub oak barrens. And what this figure shows is essentially the same pattern for all of these ecosystems, is that when restoring kind of those conditions, those, open woodland, savanna, barren sort of conditions, they're removing stand level carbon storage, particularly in that above ground tree biomass, but we're improving the habitat quality for the focal species. And a lot of these systems, have threatened and endangered species or species of special concern. And so kind of at that stand level, we see this trade-off. And they do note that, in some systems, when you get the herbaceous layer developing by opening up the canopy, you can get some soil carbon benefits over time. And then just kind of thinking more broad scale at a landscape level, you get more wildlife species and habitat diversity, and the risk of carbon release goes down, right? This is really getting to that, these systems are more resilient. And then by enhancing that resilience, we're enhancing also the adaptive capacity of those systems as well. So really kind of, I think, a nice representation of what these trade-offs look like between carbon and wildlife habitat for some ecosystems. So I'm just going to talk briefly in our remaining minutes, just to point folks to a resource to help if they're interested in learning more about how to identify actions for carbon management that are climate informed. And so this kind of comes from our work with forest managers in forest adaptation, building off of our forest adaptation resources, which was published in 2016. And importantly, there are two components to this: the adaptation workbook, which is a process to help managers consider climate change impacts and their goals and objectives for their management. And then we have developed a series of adaptation menus for different resource areas to help them kind of brainstorm what some of the adaptation actions can look like. And these menus are essentially like menus in a restaurant. They're all the possible actions. And the user kind of decides what's relevant for their particular location, their conditions, their goals, how they manage. And so one of our more recent menus is the practitioner's menu of strategies and approaches for forest carbon management. And so I'm just showing kind of just some of the really high level strategies in this menu and how they relate to both adaptation and mitigation, right? And so by adapting to resist some of those stressors, we're protecting our carbon stocks. By building resilience in our systems, we're enhancing carbon uptake when disturbances do occur. When we're guiding transition in our ecosystems, we're better setting the system up to better sequester carbon into the future. And really what this menu speaks to, and hopefully what you're coming away from this presentation with is really an understanding that, you know, there really is no one single answer for how we can manage forests for carbon. It depends upon a lot of different things, and every forest is different. Talked about climate risks and vulnerability as being one of those kind of guiding ideas to really inform how you might best manage for carbon. We recognize the importance of the site conditions, and that really informs those climate risks. And from a wildlife habitat benefit or perspective, looking at those co-benefits is important, as well as recognizing the constraints that you're operating under with your management. And so I know we're running out of time here. And so I wanted to give one very brief example. This is from Audubon Vermont's Green Mountain Audubon Center, which used our forest carbon management menu. And it's an important bird area. It's a demonstration site for foresters for the birds. And so they were revising their forest management plan for an even-aged multi-strata northern hardwood site. And really they wanted to just essentially find out, can they kind of get this triple win of both adaptation and mitigation while meeting their mission goals of forest songbird habitat for their property. Recognizing there are a number of climate change impacts that they were kind of working against, including snowpack reductions, increased pests, invasive species, those sorts of things. And this table really is just to show a number of actions that they identified and how they can contribute both to bird habitat, adaptation, and mitigation. And I'll just highlight here, they identified many places where they're just going to maintain a no harvest area. That's important bird habitat, landscape connectivity for adaptation, and of course allows trees to grow larger and retain carbon. But they identified other areas to do active management, such as group selection and creating gaps while retaining some of the snags. And, and so this is, I think, a good example of that win-win where, this is improving structure for a number of birds and diversity of tree species, which is important for some bird species. And those more structurally diverse stands are more resilient. And then by doing this, we're creating an opportunity for regeneration and, enhancing the sequestration capacity of the forest by creating these opportunities. And then they also just identified red oak as a future adapted species that they could emphasize in their management as well. So that's it. Just again, take home point here is really there's no one answer for responding to climate change. And that's true for managing for carbon as well. And so, I think if you ever hear somebody saying, well, we just need to, stop all forest management, and that's the best thing that we can do for carbon, I hope that you will kind of recall and maybe think a little bit about risk and vulnerability and some of the benefits that we can have for active management, for carbon benefits as well as for wildlife habitat. So with that, I think we are at time.
Great. Thanks for wrapping up on the hour. I know folks will have to go, so thank you for those of you who were able to join us. I did post the link on where you'll be able to access the recording. Todd and I can stay on for a few extra minutes. I was just posting the case study for the Vermont project, and we'll post, Todd will have to post the carbon menu and the Ali Kosiba citations. We'll get to those momentarily.
Yeah.
Let's see here. So I just want to grab the last question. All right. So, all right. We have a few more that came in. Todd, if you're, let's see, I feel like this could go forever. So maybe we'll stay on till no more than 10 after, but we can rattle through some of these. I think we still got this one way going, and Jim and Amanda, just let us know if we need to drop off, but we understand people will leave. Mm-hmm. All right, let's see. So many good questions. Just a few of these. So yeah, one of the folks asked specifically about deer herbivory, particularly in the eastern United States. And so yeah, if you wanted to talk about the carbon implications on some of the trade-offs and relationships with vulnerability, that would be fantastic.
Yeah, good. It's a good question and one that comes up quite frequently, and it really gets to that importance of thinking about regeneration and making sure that that there are trees that regeneration is there, and not only that, but the regeneration is the regeneration that we want, that's going to be able to contribute to to future sequestration in the forest. And so of course we recognize that these disturbance events happen, tree mortality, wind throw, those sorts of things, and that regeneration, when it's there, those trees are able to respond to the enhanced light conditions and grow very rapidly, and that's important for maintaining sequestration in a forest stand in a natural capacity. And so yeah, herbivory that is really kind of knocking back those that regeneration, or even to some extent eliminating it, really puts the stand at greater future risk, both from a carbon perspective, but also just from a resilience perspective as well, because that's not there that regeneration isn't there to kind of then help the system to rebound when disturbances happen. And deer and moose can be selective in what species they're targeting for their browse. And so that can really start to shift the composition of the future forest by really, selecting for what's there and what isn't there. And so that's one of those actions that it's kind of a tough nut to crack from a kind of an economic standpoint. If you're a small forest landowner, the options are kind of limited in terms of what is affordable at scale, whether it's fencing or other means of protecting regeneration. There isn't a lot of really good options that are cheap, that are surefire, but there are other ways that folks have been investigating. I was just at a conference a few months ago where there was a new product that was kind of a spray application that was a natural product. It wasn't based on any synthetic chemicals that they were suggesting was really impactful for reducing browse. So, if there are options such as that could be really, I think, important, particularly at either, for an economic perspective, or just kind of how much space, or how many acres a landowner might need to be thinking about treating. Those options might be really important. But yeah, herbivory is really a tough one to kind of crack, but very important from a carbon perspective.
Yeah. Todd, another piece in here is sort of building on that one. I'm jumping around a little bit in terms of how they came in, but another one related to that is another mitigation strategy that would be good to discuss is the idea of directing transformation, such as planting trees, to think about what's going to be future adapted. And so since you're talking about regeneration already, do you want to kind of take what you did and also talk about how it might relate to tree planting for transformation?
Yeah. And yeah, that's, I think, one of those aspects that I feel like you almost kind of can't get away from a forest carbon talk without talking about tree planting, because it is such an important piece. And yeah, and so we can think about this in various contexts. There's sort of afforestation, where we're taking non-forested lands that might be suitable for forest, or haven't been forest for a very long time because they've been in pasture, and converting those back to forests and planting trees. And that's, there's been a number of studies to really show the power of this kind of approach for enhancing carbon and the mitigation value of creating new forests. But it also applies to thinking about understocked stands. It also applies to thinking about stands where just that understory component, they may be well stocked in terms of the overstory, but that understory piece is kind of missing from the equation because of herbivory or some other impact. And so in those situations, doing tree planting for kind of enriching species composition can be really important. And I put up in one of those slides, I mentioned the Climate Change Tree Atlas. And this is a tool that has developed and maintained by the Forest Service, by the scientists with the Northern Research Station, that have done modeling to look at kind of habitat suitability of different tree species. And this can be a really important way to be thinking about what tree species might I be interested in looking towards to plant, whether it's in a kind of afforestation scenario or in an enrichment planting scenario where I'm just trying to enhance the species diversity, or from that context, Maria, that you posed the question of transition, how might we do this in a way to transition the stand, to really direct it in a different trajectory in terms of stand development, so that we're going perhaps, for example, away from a more softwood dominated stand to maybe something that is more dominated by hardwood species, because we expect those hardwood species to be more adapted to warmer and drier conditions. And so tree planting is one of the tools in the toolbox that we can use to kind of direct, what those forests might look like into the future, and kind of transition them to more future adapted conditions.
Great. Gosh, there's so many questions. I feel like there's 3. I'm not sure we'll get to them all. Let's see here. I think, let's bring in this last one that Patricia mentioned, because I think we haven't talked about shrublands and grasslands, and given the wide swath of managers. And so just recognizing that there's habitat conversions happening, so transfers from forest to shrubland, grassland, is reforestation critical in the West, or where do you allow for these habitat type conversions? And so obviously that depends on the context, but if you just want to talk a little bit about carbon and different ecosystem types with your background, I think that'd be great.
Sure. Yeah. In particular in the West, that this question is something that managers, are facing right now. It's not sort of a what if sort of future question. It's really happening now. And in particular, there've been some really interesting work published in the last few years showing that after wildfire, that tree regeneration in some of these areas in the West is very limited, or even not happening. And so, following wildfire, these systems are, have kind of been pushed beyond the brink and transitioning into non-forest systems. And so, yeah, what is the role for forest management in that? Well, we just talked about, I just mentioned tree planting. And so that's an option. And that's also probably an opportunity to kind of think about, well, is there a different forest type? Is there a different species that might be better suited to growing in these conditions? Is there a better, species mix that might be more resilient to fire when fire occurs, or might be more resistant to fire? And so those are some important questions to consider. But there's also the question of, things are getting drier in some areas in the West. Fire risk and fire occurrence, fire severity, all of these things are increasing and are not projected to do anything other than continuing increasing. And so it does beg the question of, are some of these lands more suited to being converting to other ecosystems? And that's a tough question. That's a tough question for managers to face, and there is no one right answer. And I think from my perspective, it gets back a little bit to, what are we looking for in terms of our goals for these lands? And can we maintain some of those goals with a transition to another ecosystem type, whether it be wildlife related or recreation or water related? And there have been some papers suggesting that, in these really fire prone ecosystems, that perhaps a focus on below ground carbon storage is really more appropriate, because that carbon is much less vulnerable to loss than above ground carbon. And so I don't think, there's any one answer. It's really going to be situation dependent, but I think understanding kind of these dynamics between above and below ground carbon, how they change and what the risk is, and what's the climate projections look like for that risk. That's all very important to kind of put together and makes some informed decisions about how to address management on these lands.
Awesome, thanks, Todd. Great. I'm going to close her down there. I'll put in a plug that we're working to develop the Atlas for the West, so we don't have it. We'll share some other links and resources. In terms of wrapping this up, thanks for everyone who stayed on. We still have a tremendous amount of people. We appreciate your time, and so we will post the presentation on the site that has been mentioned for this particular webinar series. Jim and Amanda come on and feel free to add to if I forget anything for the closeout, but we'll post the presentation there. Asks Todd to share his slides as well, and we're also collecting up the questions from this particular session, and we'll try and address any unanswered ones and send them out via email. So thank you to everyone who helped organize this webinar series. Thanks for attending, and thank you for our interpreter for joining us and doing an excellent job as well. We always appreciate that. So think that is it. Thank you, and have a wonderful rest of your day. Thank you, Todd.
Thank you all. Bye-bye.